Welcome to this explainer. Look, if you've been pouring months into building AI projects, only to have your portfolio just instantly rejected by recruiters, you are definitely not alone. Today, we're going to diagnose exactly why those standard, run-of-the-mill tutorial projects are failing you. And more importantly, we're mapping out the exact systems-level projects that real engineering teams are desperately trying to hire for as we head into 2026. Let's get into it.
We've got to start with a hard truth, straight from the hiring manager's desk. Most AI projects people build after following tutorials are completely useless if your goal is to get hired in 2026. Honestly, ouch. But it's true. Those basic chat clones, the fake AI apps that don't really do anything, recruiters have seen them literally 1,000 times, and they just skip right past them. Proving you know how to call an open AI API just isn't enough to land the interview anymore.
So, to actually stand out, you've got to do a total pivot. Move away from what I call vibes-based AI development and start proving your professional engineering competency. Recruiters are hunting for folks with a true systems-level understanding. They want to see that you can build down at the infrastructure layer, handle messy constraints, and manage complex orchestration.
Okay, so here is your 2026 engineering portfolio blueprint. We're looking at 6 key areas: MCP infrastructure, offline constraints, a RAG eval harness, multi-agent systems, voice AI, and fine-tuning. Section 1, MCP infrastructure, building at the foundation.
Released by Anthropic in late 2024, MCP stands for Model Context Protocol. You can kind of think of it like the USB-C port for AI. It's this universal standard interface that plugs AI agents into external tools, like a calendar, a database, or internal APIs. Most devs out there are just sitting on the consuming end, right? But if you actually build an MCP server yourself, you instantly prove to recruiters that you can operate at that absolute foundational infrastructure layer.
So what does this look like in practice? Well, you could write a server that exposes a personal task management system. Or maybe one that lets an AI query a local SQLite database using natural language. You could even wrap a public API, like a flight tracker or a course catalog, so a language model can call it with structured inputs. Doing this in Python or TypeScript and testing it locally shows you know exactly how to wire LLMs into actual real-world business workflows.
Moving on to Project 2, Offline Constraints, Engineering for Privacy. Here's the deal. Imagine you're building a tool for a healthcare startup, right? Doctors are uploading sensitive patient notes. Because of HIPAA regulations, sending that data off to OpenAI or Anthropic is legally impossible. It is a complete non-starter. This is a massive, real-world constraint that entire industries, finance, legal, healthcare, are heavily organized around. If you build an app where offline deployment is the core design constraint, rather than just a neat little add-on, you become incredibly valuable to a hiring team. To pull this off, you need the right tech stack. Google's Gemma model is a fantastic starting point here. It's designed for local deployment and runs like a dream on Apple Silicon. You'll use Allama to manage the local API endpoint. But here's where you really get to flex those engineering chops. You have to make the hard decisions about quantization levels. You're actively balancing speed versus quality. You're managing shorter context windows, and you're dealing with streaming UIs, so the app doesn't feel sluggish or broken to the user. Up next, Project 3, RAG eval harness, moving beyond vibes. This right here addresses the single biggest trap in modern AI development, the vibes-based app. You know the one. It looks absolutely flawless in a 30-second demo, but the second it hits production, it hallucinates wildly, pulls total garbage data, and just falls apart. To fix this, you have to show you understand evaluation-driven development. First, instrument your retrieval logs to track what chunks are actually being pulled. Then, handcraft 50 to 100 ground truth QA pairs that target your system's specific weak spots. Finally, build an automated scoring harness around those exact failure modes. You're essentially building an AI regression test framework from scratch. And here are the exact metrics and tools hiring managers are desperately looking for when they review your RAG pipeline code. For factual answers, you want an exact match metric using a tool like Ragas. For open-ended stuff, you'll implement an LLM as a judge flow using DeepEval. And to measure chunk relevance, you rely on telemetry logs through something like BrainTrust. I can't stress this enough. Implementing this level of rigorous automated testing is exactly what separates a junior dev from a professional engineer. All right, Project 4, Multi-Agent Systems, Designing for Robustness. Gartner actually projects that by 2026, 40% of enterprise apps are going to use task-specific agents. Now, most people just wire up 2 agents, get one good output, and call it a day. But in the real world, when a harder task pops up, Agent A makes a mistake, Agent B inherits it, and boom, you've got a massive chain of compounding logic errors. So to prove your skills, try building a robust competitive research tool. You'll need a planner that receives and validates requests, a researcher that runs web searches, and a synthesizer to write the report. The absolute key here? That planner must be designed to catch failures and retry, rather than just passing bad data downstream.
To actually orchestrate all of this, you should use LangGraph. By exposing your state machine, making those transitions visible, and logging every single agent, input, output, and tool call, well, that is exactly the level of granular system control recruiters are dying to see in a portfolio.
Project SIME, Voice AI, building for low latency. Voice-first AI is a totally new product category that practically didn't exist 2 years ago, and companies are aggressively hiring for it. A great way to prove you can do this is by building a hands-free study coach. You talk to it, it quizzes you, listens, and adjusts on the fly. But to make it work, you absolutely have to conquer latency. You'll need to chunk streaming audio using Whisper, use an LLM to manage complex session states like space repetition logic, and output the response using a lightning-fast model like Cartesia. Hitting those sub-2-second round trips, that is a highly technical and deeply impressive project to show off.
Finally, Project 6, Fine-Tuning, Bridging the Cost Gap. Look, before you even touch fine-tuning, you have to understand when it actually makes sense. We're currently seeing this massive split in the ecosystem. On one side, you have the giants, frontier models like GPT-4o, which give you incredible reasoning, but at a really high cost. On the other side, you have smaller, hyper-efficient models like Llama or Gamma. Fine-tuning using techniques like LoRa is basically the financial bridge between these two worlds. You use it when you have genuine proprietary data, or when you're operating at a scale where hitting a massive frontier model for every single request will just bankrupt you.
If you decide to take this on, there are a few non-negotiables. First, ruthlessly curate your data. I mean it. 100 perfect, hand-cleaned examples will beat 1,000 messy ones every single time. Bad data is literally the #1 reason fine-tuning fails. You also need to define your evaluation metrics before you start training with a framework like Unsloth. And here's the ultimate test. If your fine-tuned model doesn't beat both the base model and a big frontier model like Claude on your specific test set, the project isn't complete.
So as we wrap up this explainer, I really want you to ask yourself this question. Is your portfolio just proving that you can use AI, or is it proving you can actually build the systems that power it? It is time to officially leave the tutorial trap behind. Just pick one of these 6 projects, whichever one sparks your curiosity the most, and start building the hardcore infrastructure that 2026 engineering teams are actively paying top dollar for. Thanks for hanging out with me, and happy building.